Potentiometry. Attention! Silver nitrate is an oxidizing agent, can cause severe chemical burns on the skin and eyes, and is toxic to aquatic life with long-lasting effects. I don't take any responsibility for damage done to persons or property caused by the recreation of this experiment. For the potentiometry, the following is needed: a barrette, a silver chloride electrode, a beaker, a stirring bar and stirring plate, and a potentiostat for measuring the voltage. The silver chloride electrode is an indicator electrode made of silver and a reference electrode, which is a silver wire that is coated with silver chloride. This is submerged in a reference electrolyte. A porous membrane enables the exchange of ions. It is a galvanic cell which can also be drawn like this. The right half cell is made of the reference electrode that is in the reference electrolyte. This is connected with the left half cell through the porous membrane. The latter consists of the indicator electrode and the solution which should be measured. Due to the potentiostat having a very high resistance, no current is flowing and only the voltage between the two electrodes is measured. This is depending on the concentration of chloride ions in the unknown solution and the solubility product of silver chloride. For the measurement, two solutions were prepared. First, a 0.1 molar standard solution of sodium chloride. This was made by dissolving 1.46 grams of anhydrous analytical grade sodium chloride in 250 milliliters of distilled water. Before use, the solution should always be shaken. The second one is a 0.1 molar silver nitrate solution. This was made by dissolving 4.25 grams of silver nitrate in 250 milliliters of distilled water. The water content of the silver nitrate was neglected because the concentration of this solution was going to be measured. This solution has to be stored in the dark because silver nitrate is sensitive to light. Then the barrette was filled with a sodium chloride standard solution, and it was taken care that no air was left in the apparatus. It was overfilled to make it possible to remove the air from the stopcock. After that, the solution was drained until the surface was at the starting point. With a 10 ml volumetric pipette, a sample was taken from the silver nitrate solution. Just before the measurement, the cap was removed from the electrode. The cap contains the reference electrolyte to keep the electrode from drying out, which has to be washed off with distilled water. The electrode was placed so close to the bottom that the stirring bar was still not able to hit it. Then the distilled water was added until the membrane of the electrode was submerged. The refill opening has to be open in the measurement. At the beginning, the solution was added in large portions. Due to the formation of silver chloride, the solution became turbid. Usually, the titration is done several times, where the first one is done sloppy to find the equivalence point. From the second time on, the size of the portions is then made smaller just before the equivalence point. The concentrations were almost the same, so the equivalence point had to be around 10 milliliters. The measured values were then written into a table and the value of the slope was calculated. It can be seen that the slope increases to a point and then decreases again. When it is plotted, the following curve can be observed. Usually a solution containing the halide ions is titrated with silver nitrate, so this curve is the other way around in comparison to literature. The equivalence point is at the point with the highest slope. When the slope and the volume are plotted, a distinct peak can be seen. This was at 10.5 milliliters, which could already be seen in the table. Now, the concentration of the silver nitrate solution can be calculated as follows. The amount of the sodium chloride solution in liters is multiplied with its concentration and divided by the volume of the silver nitrate sample. The value had to be rounded up, so a concentration of 0.11 moles per liter was found out. This can now be used to determine the concentrations of unknown solutions of halide ions. So with the same setup, the concentrations of iodide or bromide ions could also be measured. Due to silver chloride, bromide and iodide having a different solubility product, these can sometimes be determined simultaneously. Then the titration curve contains equivalence points for iodide, bromide and chloride. At the end, the electrode was taken out of the solution, washed with distilled water and wiped with a paper towel. The cap with the reference electrolyte was put on again and the refill opening was closed. This was the potentiometry. I hope you enjoyed. Please rate and comment. If you want to see another quantitative detection, you can watch my video about 3,5-dinitrosalicylic acid here, or you can watch my latest video here.